Hi everyone, thank you for joining us for another episode of UNESCO Talks. I'm your host, Gabby Menezes. Today's guest is Professor Iain Stewart, who is a geologist and UNESCO's chair of Geoscience. He's here to explain to us why we should care about geoscience and how geology relates to our everyday lives. Iain, thank you so much for joining us.
Thanks, Gabby.
So maybe the most obvious question is, what is geoscience?
What is geoscience? So geoscience is the study of the planet. So it's a mixture of geology, which tends to focus on the solid rock beneath us, but it also takes into account, the soil, and increasingly also the different spheres. We think of the hydrosphere, water. We think of the cryosphere, which is ice. So the ice sheets, glaciers, etc. And then increasingly the atmosphere. So that whole thing now is an integrated system, the Earth system, and geoscience tackles that.
So why should we care about it? How does it relate to people's lives? When you think about rocks and tectonic plates and things, it's not really something that seems to have much of a day-to-day impact.
No, it feels very far removed from people's everyday lives. I mean, you see it suddenly on the television if a volcano erupts or there's an earthquake or something. And actually, in that sense, it seems to be, bad disasters, etc. But the reality is that almost everything people use, comes from the earth. If you can't grow it, you have to dig it up. And so it comes from these natural resources. And that means that actually many of the absolutely the most critical issues for society, probably over the next few decades, is going to be related to the planet. It's where we're going to get our water from. Increasingly, the surface water sources are getting polluted, etc. And there's large amounts of water in the subsurface. The metals that we need for the energy transition to move from that high carbon fossil fuel past to the low carbon future depend on minerals that are scattered around the earth in various kind of places. That whole shift from oil and gas to solar, etc., is bringing in a whole set of new materials. But then we also have things to do with climate change. Climate change is a huge issue. And then things like volcanoes and earthquakes. How do we keep people safe from that? So as society gets bigger and more complicated, the relationship with the earth gets more complicated. And so what geoscience brings is that integrated thinking. We steal from every other science. We steal from chemistry and physics and maths and biology to try to understand it. And I think it's that holistic thinking that's probably our biggest tool in the challenges ahead.
So when we're thinking about sustainability, which is becoming more and more of an issue, what kind of solutions can we look to geology and geoscience for?
I think there's a couple of things. So one thing to recognise is we live on this planet that has been sustainable for 4.5 billion years. 4,567,000 years has been kept itself going with life. So the water that we have now, we think is probably the same amount of water we had right at the start. So there's something about the earth as a recycling engine, recycling minerals and materials and waters, etc. So there's that thing that we live on a planet that's sustainable, but humans and society isn't. I think the other thing is this change in the way that that we live in this habitable world, and it's maintaining that habitability, that viability for life that's so critical. And so geology gives a perspective into the past about what happens when you mess around with that. So humans weren't there, simpler life organisms were, but we have plenty of examples of what happens, for example, when you do natural global warming. Generally, it's not good for life. Life takes a tumble. So we could take some of that wisdom. But I think the reality will be things like really at the sharp end, resources, natural resources, so energy, particularly in minerals. How do we use those sustainable, the circular economy, all this type of things. And then the sustainability of our cities, which is where more and more of us live, from hazards, or for climate change, or for lack of water scarcity.
Is there one solution in your own sort of work or research that has surprised you and that you found really innovative?
I think one of the things is the complexity of human society in relation to the complexity of the planet. So again, I think what happens when you study the planet is you have to look at it from all these different angles. And I think that integrated science is what we need. I did I think a few years ago, they locked me in a box in a place called the Eden Project down in southwest England, and they locked me in an airtight box for 2 days, and they took the oxygen levels down to 12%, which is very close to when you start to have oxygen sickness. And in there, all I had was high photosynthesizing plants to keep me alive. And so for 2 days, I just was there, breathing in the oxygen, it was the small amounts of oxygen, breathing out carbon dioxide, of course, increasing it. And basically what we saw was those plants kicked in, and over the 40 hours, my oxygen levels went up and up and up. But what that showed me was there was it wasn't that much difference from the size here, this block packed full of plants, and that was just to keep me alive. So you start to realize, gosh, out there in the real world, to keep me active and keep all of us, the amount of the biosphere that we need. So every so often, geology gives you these little insights into these contemporary issues in a completely different way.
Wow, what made you decide to be locked into a little box?
I don't think I had any decision to be made in it. I was doing a television program called, it was about the life of plants, the story of the geological story of plants on Earth, how to grow a planet. And that was what was decided, to show photosynthesis, the importance of photosynthesis in a different way. So there was an old experiment by Joseph Priestley, who discovered oxygen. And he had a little bell jar, and he put a mouse in it, put the bell jar on it, and after a day or so it died. And then eventually he put another mouse into it with a plant in it. It died, but it took longer to die. And so I was the mouse, basically, in this modern day Priestley experiment.
And you're currently the UNESCO chair of Geoscience and Society. What kind of work are you doing, and why is it so important?
Well, I think, part of the reasons that geology is unfamiliar is that geologists love talking to geologists. We have this strange affliction to rocks, so that's kind of our world. And so traditionally we've not felt the need to reach out and talk about the importance of the subject. But as I was saying, most of the big issues are now at this interface between the science that we do and society, and we are starting to feel frustrated. I think the community feels frustrated that it's not included at the top table on discussions about sustainability because it's not made itself available. So really, that interface is communication, and that communication is trying to explain complex technical science to non-technical audiences. Now that might be a local community, or it might be top decision makers, but all of them share that unfamiliarity with the science, and a defensiveness maybe about the science as well, and a desire for solutions and answers, not, we can explain why that happens. It's about, okay, what are we going to do about it? And that, what are we going to do about it, is by far the hardest thing, because that brings in not just the scientific element, but the social element, the economic element, the political, cultural elements that geologists, because we've just had to deal with rocks, haven't had to deal with in the past.
So actually it's key that wider audiences like policymakers, people who are looking at kind of how we are getting energy, really understand the basics of geology.
Yeah, and it's hard because we they don't have to do a university course in geology. They need a very quick 101 primer on what's important. And so I think we often blame the decision makers or blame the media or something for that inability to understand. But we need to change the way that we react and kind of try to convey this, because the problem's with us. We've got our own language, etc., etc. And but we have great things. I mean, geology is very easy to communicate. We've got earthquakes and volcanoes, we've got dinosaurs, we've got some of the best kind of shop window, really, and we've got the planet, and people travel and they love going to places and see landscapes. So we've got everything there. We just need to reconfigure the way we approach the public.
And of course, when you talk about earthquakes and volcanoes, this is how some people are most impacted by geology. And so there is an educational element as well when we're talking about these kinds of hazards.
There is, so geohazards is this, with tsunamis and landslides, there's all this death and destruction that goes with the planet. And I think geologists have a role in about the hazards, but it is important to recognise that the really critical thing that people care about is risk. So it's not so much the process, but they want to know, does it affect me? So if I live in a city, am I going to be affected by an earthquake or something? And not just that, if I am, what can I do about it? And there's a tendency for geologists to stop at the hazard, so we can explain the physical process and then stop. Our job's not to go into the cities and get our hands dirty with planning or social kind of changes that might make things. So I think that there's an imposition now for geologists, for geohazard specialists, to be working with communities, working alongside social scientists, people in the humanities, people in the creative arts, finding new ways to convey what our hazard means for people's everyday lives. So that it's shifting it from hazard to risk.
So actually it's really important that people understand the basics of geology and, in particular, policymakers, educators. How do you think that we can reach a wider audience?
Well, I think geologists, like most scientists, can't just stay in that scientific world. These days you need to be out, you need to engage in the wider society. That means you need to be taking your science and embedding it in education, but also increasingly into kind of the social dimension, economic dimensions, and the cultural dimensions of what we do. So we work with people, with communities, and we need to understand those communities. So UNESCO is a really good organisation that spans, that reaches out to all of those areas. And so under the umbrella of UNESCO, in particular, I've got the UNESCO chair, it's a great platform to bring those different groups together. You can work with the creative arts, you can work with social scientists, humanities, and you can work with scientists. And the result is this amalgam, this really creative amalgam that you can really drive forward. And that's what's fantastic about UNESCO.
And one of the things UNESCO has done is designate geoparks, which I know you work a lot on. Can you explain the value of that and what they are?
Yeah, so UNESCO's got the World Heritage Sites, which is the most famous designation, but they're a top-down kind of national appreciation of the gems of the natural world. But geoparks are the opposite. They're bottom-up, so communities that have an affinity, are rooted into the bedrock, literally, the bedrock of their area, and where that bedrock has led to economic development, or mining, for example, particular cultures, or tourism, or art. And basically that community then decides or argues that their area is so special that it warrants being a geopark. And it's a complicated process. There has to be amazing geology, really good geology. But probably more important than that, certainly for UNESCO, is it has to genuinely connect with the community. The community have to feel as if they own that piece of real estate, that geological real estate. So geoparks started in Europe, lots of them across Europe. We've got about just less than 10 in the UK. But then what happens is they went global. UNESCO took them on to these global, and so now we're trying to develop them around the world. There are a lot of them in Southeast Asia, a lot of them in Latin America now, but Africa, Middle East still needs to have some more. And what's amazing about geoparks is that they're catalysts for socio-economic development. So you can go into a small community, very rural or peri-rural community, and connect them to their rocks, their landscapes, their landforms, and then that becomes the economic driver for development.
Can you give us an example of a few geoparks where you've been really impressed with how development has happened?
I first got interested in the geoparks in my backyard. I'm in Plymouth in southwest England, and a geopark was in the Torbay area, so just very close. It's called the English Riviera Geopark. And when I went to see it, I thought, wow, there's not much geology here, because I always had my science hat on. But they were doing things with artists, with writers. They were having lots of things with kids, and so you gradually look at this and you see all these wide audiences engaging with rocks and landforms, which is of course what we're really wanting to happen. So that was my first impression of that. But then as you go around the world, you see this replayed again and again. And so there's so Lesbos, for example, in Greece, is a geopark. Well, that's a geopark because it's got these amazing, it's volcanic, but it's also got these petrified forests from millions of years ago. But that's an area that now has a huge refugee from Turkey into Europe, and Lesbos is one of the places where they camp. So they then have these things where they're using the geopark as something to connect with the refugees and talk about immigration and migration. There's other geoparks that are really affected by climate change, and so the geopark becomes this platform to engage the people, ordinary people that are coming to see the beautiful places, to engage them into climate science. So there's a huge potential for the scientific community to use geoparks to advance this popular understanding of these critical issues, but more importantly, to get back that local situational knowledge of the people that actually live there. And that's in my view, much richer than World Heritage Sites, where you go and they're beautiful, you take photographs and you leave, but you don't engage with the community that's there.
So the communities really have their own way of protecting these places, of engaging with these spaces. Can you give us maybe just one example of how this has surprised you?
Yeah, so for example, a lot of communities, if they've got really good geology, often the people that go there are geologists, and they'll often take the rocks, sometimes all the fossils, and they'll take them away and they'll put them in laboratories. But of course that local community is losing its heritage. And so actually there's a very nice Brazilian geopark where what they did was they taught the local people about the importance of these fossils and how to preserve them and to keep them. And then they had this kind of sustainable marketing of fossils. So you couldn't just have people coming in and just taking them. The locals understood the value, both the scientific and the heritage value, and that became part of the economic return. So they started to make money in a sustainable use of the fossils. And you can see this in different examples all around the world.
Iain, thank you so much for joining us on UNESCO Talks. You've certainly convinced me that we should all be taking geology more seriously in our everyday lives.
Thanks, Gabby.
And thank you for joining us. Please, if you have any comments or queries, leave them in the chat and we will get back to you, and join us again for another session of UNESCO Talks.